Welcome. This is the lecture for Chapter 6 on demand. This chapter is sort of the pinnacle of everything we've been studying so far. In this chapter, we put together budget constraints, preferences, prices, income, and we begin to see how these things can change. We use an analysis strategy here called comparative statics. What that means is we look at a system in one state, and then we look at the same system in a different state, but we don't pay attention to how it transitions from one to the other. We just look at the results. Let's see. Oh, something else about this chapter. There's a lot of new stuff in this chapter. Some people would find it difficult. I don't see it as difficult. I just see it as voluminous. There are several new graphs, new vocabulary. I don't think any one bit of it is that hard. There's just kind of a lot of it. So take it slow and steady. Watch this video, read the chapter more than once, and you should be okay. If not, let me know, and I'll help you. Okay, first, we're going to look how choices change when a price changes. Here, let's see if I can make the laser pointer work. Okay. This is our standard graph of consumption bundles. On the horizontal axis is the quantity of commodity 1, X1, and this is the quantity of commodity 2, X2, and we're looking at the price of commodity 1. We're assuming that your income, here M, and the price of commodity 2 are both fixed. So we're only going to vary the price of commodity 1. Let's start with commodity 1 having this particular price, P1 prime, which generates this budget constraint. Now, what happens if that price changes? If the price goes from P1 prime, which gives us this budget constraint, to P1 double prime, the price goes up. Then the budget constraint will swing inwards. Because if you spend all your money on commodity 1, instead of affording this much, now you can only afford that much. But if you spend everything on commodity 2, nothing changes. And if the price goes up even more, then it would go from this budget constraint to this one at the even higher price of P1 triple prime. Now, at the initial price, this is the budget constraint, and I've added indifference curves, nice, well-behaved indifference curves. And you can tell visually that although I have this a bit off-center, it actually should be around here. This is the consumption bundle with this budget constraint and these indifference curves that this person would choose because it gets them to the highest possible indifference curve. Now, if the price of commodity 1 goes up so that now this is the budget constraint, we can see the person would re-optimize to here because this is the best they can do, the highest indifference curve they can get to. And if the price goes up again, then they'd be here. Well, this graph on the left, it plots quantity of thing 1 against quantity of thing 2. But that's not the only way we can graph this. Because we're keeping income and we're keeping the price of commodity 2 fixed. Let's say we're only interested in commodity one and how consumption of commodity one changes as we swing through all these different prices of commodity one, as P1 changes. Well, if we're not really worried about what happens to commodity two, then we could also plot this here. On the horizontal axis, we still have quantity of commodity one, the star indicating that these are all the optimum points. And on the vertical axis, price of commodity one. Well, at this first price of commodity one, P1 prime, we know a person will consume X1 star of this thing. So we can plot that. X1 star and the price P1 prime. So we get that red point is that one. Now, if the price changes and goes up to P1 double prime, then the person will consume less of X1. X1 will be smaller because they're consuming a smaller quantity of commodity one. They'll be here. Higher price, lower quantity. Well, we can plot that as well. And it would be here. Smaller quantity of commodity one and a higher price. And we can do this again for an even higher price of commodity one. I hope you see what we're getting here. If instead of discrete prices of commodity one, P1 prime, P1 double prime, triple prime, what if we looked at all the different prices in a continuous fashion? Well, then we'd get this. It's the demand curve for commodity one. At all the different possible prices, this shows how much this person would buy of commodity one. That's where demand curve comes from. Let's see. Now, here in the left graph, we just show the consumption bundles, quantities of thing one and thing two purchased at 3 different prices. But just as here on the right, we made it continuous, looking at all the different prices, we could do the same here on the left. Instead of 3 dots, we could have some sort of curve. For these preferences, it would be this green thing. And your textbook calls that the price offer curve. I should point out that that is not, the terminology in this book is a great book, but it's a little non-standard here. When I was taking this class back when the dinosaurs roamed the earth, this was called the price expansion path. I think that's still a more common term. So if you ever see the other name, price expansion path, it's the same as price offer curve. Oh, let's see, that's a definition of it. Now, what does the price offer curve or price expansion path look like for Cobb-Douglas preferences? Here are Cobb-Douglas preferences for 2 goods. Now, from 2 chapters ago, I believe, we derived the demand functions for commodity 1 and 2 for the general form of Cobb-Douglas and came up with these. For price of commodity 1 P1, commodity 2 P2, and income M, the quantity demanded of commodity 1 is given by this formula, and of commodity 2 by that formula. And this is what it would look like for those preferences. Notice that for a Cobb-Douglas utility function, the price offer curve is linear. And this is what the demand curve would look like for commodity 1, and it would look the same for commodity 2. Now let's look at the price offer curve for perfect complements, what they look like. Well, perfect complements have this utility function, and the demand functions are this. The quantity demanded of thing 1 and thing 2 will be the same. Your income divided by the sum of the prices. Also note, the book and these initial slides sometimes go back and forth between income being lowercase m or being lowercase y. Y is actually more common in econ. Income individually and also national income, if you're dealing with macro, are generally given by y, just because that's the way we tend to do it. Okay. Now, as the price of commodity 1 with perfect complements drops, then we're going to end up purchasing the same quantity of x1 and x2. It'll just be our income divided by the price of x2. Look up here. If the price of x1 goes to 0, price of commodity 1 goes to 0, then this term falls out, and m over p2 is what we have here. As the price of commodity 1 goes in the other direction, gets infinitely large, well, you can see from this term, this approaches 0. Same as you see there. So, this would be the price expansion path, or the, oh goodness, I've forgotten. Price offer curve. There we go. That's Dr. Varian's term. Is linear. And if you plot these different points, you get the demand curve. Now let's look at the same thing for perfect substitutes with this utility function. Note that these are perfect substitutes that you want to consume at a ratio of 1 to 1. Keep in mind that even though this is the simplest example, it doesn't have to be 1 to 1. If utility was 3x1 plus x2, where you wanted to consume these in that ratio, 3 of this to 1 of that, they would still be perfect substitutes. Just make the math a tiny bit more complex. But this is the simplest case of perfect substitutes. Then the demand functions will be this. If the price, if the price of commodity 1 is greater than the price of commodity 2, you won't buy any of it. You spend all your money on commodity 2. If the price of commodity 1 is lower than commodity 2, then you'll spend all your money on it. As we see here, your income divided by the price of commodity 1. And the flip for, for demand for quantity 2. As perfect substitutes, it means you don't care which one you buy. Think Coke and Pepsi, if you really had no preference. You're going to buy whichever is cheaper and 0 of whichever is more expensive. Okay, now here. This graph can be a little misleading at first. You're used to seeing budget constraints as straight lines and indifference curves as, well, curves. But here, because they're perfect substitutes, this red line and this blue line and this black line, these are indifference curves. They just happen to be linear because these things are perfect substitutes. This is indifference curve 1, indifference curve 2, indifference curve 3. This line is actually your budget constraint. Now, because you're going to spend all your money on whichever is cheaper, you're always going to be at an endpoint, a corner solution. Now you can see, ignore the indifference curves for the moment. Just look at this budget constraint. If you spend all your money on thing 1, you can buy this much. If you spend all your money on thing 2, you can only buy that much. That tells me that the price of thing 1 is lower. Therefore, because they're perfect substitutes, you'll spend all your money on thing 1. And if you plot these, note here, as the price of thing 1 drops, this endpoint of the budget constraint is going to start swinging in. That point will stay where it is. Well, eventually, if this swings in, it's going to reach this point here, where the budget constraint exactly overlaps this indifference curve, which is what you see here. It's why it looks like you're missing a line. Well, you're not. This blue line is an indifference curve. It is also the budget constraint. At these particular prices, in particular price of thing 1 at P1 double prime, then your indifference curve and budget constraint perfectly overlap. Well, what does that mean? That means that you're going to spend all of your money, so you'll be on somewhere on this budget constraint line. But since all of the points on the budget constraint give you exactly the same utility, you don't care where you are. So the quantity you will purchase at that price is somewhere on this segment. And you don't care because they give you exactly the same utility. And then as the price of commodity 1 drops even further, once it moves just a smidge below this point, well, I'm sorry, the price is, I've been saying price is going down. As this is the price going up, I apologize. As the price of thing 1 goes up, it moves to the left. So at this point, just to the left of here, the price of X1, of commodity 1, has gone up, so it's just slightly greater than the price of thing 2. At that point, you switch from buying only commodity 1 to, at this one exact price, you're indifferent, and the price goes up just a bit more, and you switch all to commodity 2, which is reflected here. And as the price of X1 goes up even more, you end up on this part of the segment. Okay, the inverse demand function. This sounds a little scary, I think. Maybe. It's really not. What is a demand function? Well, it's something that shows the relationship between price of a thing and quantity of a thing that people buy. The inverse demand function is exactly the same information. It's just expressed the other way around. Normally we ask, given this price, what's the quantity going to be? You can ask it that, so you have the same information, the same relationship between price and quantity. You can just ask the other way around. You can say, well, if the quantity is this, what would the price have to be? It's the same thing. Let's see. So you would just solve, instead of having X on the left, you'd have price on the left. You just solve for price instead of solving for quantity. Let's see. Okay, that's what happens when the price of thing 1 changes. But now let's look at what happens when your income changes. The prices of thing one and thing two both stay the same, but your income changes. Again, they're being inconsistent, calling income M and also Y. Let's look at what happens. Okay, here, if your income is kind of low, so that, let's say it's at M prime, which gives you this budget constraint, you're going to optimize with that consumption bundle, because that's the highest indifference curve you can get to, most utility you can get. Now, if your income goes up, say from M prime to M double prime, your budget constraint is going to move outward to here. Notice the slope will always stay the same, because the slope of the budget constraint is determined by the relative prices of thing one and thing two. But here, we're holding the prices constant. The only thing we're changing is your income. So the slope of the budget constraint stays the same. It just moves outward as you have more income. So you would optimize to here. Now, assume your income goes up even more. You're at M triple prime. Well, then you'd be on this budget constraint, and you'd optimize here. Well, if you have those three optimum points, you can plot them. If your income is low, you'll consume this bundle of X1 and X2. A little higher, this bundle. A little higher yet, this bundle. Now remember, if the prices change, right now we're looking at how income change affects your choice. But remember, before we looked at what happens to your choices if the price of thing one changes. Well, we could plot it until we get the whole line, the price offer curve. Now we're looking at how your choices change if your income changes. We can do the same thing. Instead of just looking at the consumption bundle at three discrete incomes, we can look at all of the possible incomes. And we get this new curve called the income offer curve. The way I learned it, this was the income expansion path. Both terms are acceptable. And just like before, with the price change, we could also plot all of the different quantities of thing one you buy at different prices on a graph of quantity of thing one, price of thing one. And we got the demand curve. It's price that we're changing. So it's price that we plot on the vertical axis. We can do the same thing here, except we're not changing price. So you don't want price on the vertical axis. We're changing income. So we can show on this right-hand graph how the quantity of of thing one you buy changes as your income changes. And we get this curve. This is called an Engel curve. And this is the Engel curve. This is the Engel curve for commodity one, how your consumption of it changes as your income changes. Here, how your consumption of commodity two changes as your income changes. Let's see, next topic. Give me just a moment. Engel curve. Okay. here. All the examples in the textbook, I believe all of them, pardon me, show angle curves that are straight lines. Is that the general case? No, it is not. It's a simple example. Angle curves are straight lines if the consumer's preferences are homothetic. The new word for you, homothetic. Technically, homothetic preferences mean preferences the utility function that expresses them is homogeneous of degree 1. If that makes sense to you mathematically, fine. If not, don't fret. Homothetic preferences have this form. They satisfy this condition, rather. They're two consumption bundles. This one, where you consume some quantity of X1 and of commodity 1 and some quantity of commodity 2. And here's a different bundle of those same two commodities. This symbol means you strictly prefer this bundle over that one. If that, assuming preferences are homothetic, that means that if you multiply the quantity of things in both bundles by the same constant, a positive constant, so that you now are comparing, let's say k is 3 times as many of this, 3 times as many of that in this bundle, and 3 times as many of this and 3 times as many of that in this bundle. That you will still strictly prefer this one over that one. It also means the marginal rate of substitution is the same anywhere on a straight line drawn from the origin, which is difficult to imagine, I expect. Here is, I hope, a little more intuitive explanation of homothetic preferences. Let's assume you have two consumption bundles. This is commodity 1, this is commodity 2. And the two bundles are this one, where you have 5 of whatever commodity 1 is, and 10 of whatever commodity 2 is. And this blue bundle is the other way around. 10 of the first thing and 5 of the second thing. They don't have to be inverse like that, just makes the example simple. Now, as you can see from this graph, both of these bundles are on the same indifference curve, which means you're indifferent between these two. They give you equal utility. Now, let's assume that we double both of them. So this one that had 5 of the first thing and 10 of the second now has 10 and 20. And this one also doubled from 10-5, it's now 20-10. So this one doubles to become this point, and this bundle doubles to become this one. Preferences being homothetic means if you were indifferent between these two, you must be indifferent between these two as well. It also means that the indifference curves will be the same shape. Now, that doesn't have to be the case. Actually, in the real world, it's usually not the case. Here's an example of non-homothetic preferences. Let's assume that this thing 2 is how many movies you get to watch. And thing 1 is food. Well, maybe you're indifferent between these two combinations of movies and food. But as your income goes up so you can afford more of both, well, this point with a lot of 20 movies and 10 foods gives you certain utility. But this point, with 20 food and 10 movies, let's say that, you don't really need 20 foods. 10 is good, maybe 15 would be better. But when you get up to 20 foods, units of food, maybe you're getting kind of full. You don't particularly get a lot of utility from more food. You're always going to like more movies. Well, that could mean that in these 2 points, maybe you'd rather have more movies and a little less food. This combination of a lot more food and a few more movies doesn't make you that much happier. In that case, you would not be indifferent. You would strictly prefer this bundle over that one, which means it's on a higher indifference curve, and you'd have another indifference curve down here. This is an example of preferences that are not homothetic. Another way to think of homothetic preferences is that as your income goes up, your preferences scale proportionately. Oh, also, let's see if I can draw this. I'm drawing with a mouse, so this is going to be ugly, but remember before it said that the marginal rate of substitution will be constant on a straight line from the origin? Well, look here. And let's pretend this is a straight line. Whoops. And let's also assume I intersected that point that I was intending to. As your income goes up, and you can afford to buy more of both, the consumption bundles you will consume will fall on that straight line. And if I can do it for the blue one, equally badly, because drawing with a mouse is not natural, you would get the same pattern. And notice here, let's see if I can do this. The slope here is the same as, whoops, if I can see my mouse. Okay, I can't see my mouse. The upper right point, the blue one at 2010, the slope of that indifference curve at that point should be the same as the slope of the indifference curve at the other blue point, the one at 10.5. And you should see the same thing for the two red points. I know it doesn't quite look that way, but in a properly drawn diagram, it would be the case. All right. Here another example of non-homothetic preferences, quasi-linear preferences. Remember, quasi-linear preferences means they're linear, but only in one argument. Here, utility is linear in the quantity of x2, but not in the quantity of x1. Maybe it's the square root. Oh, let's see. Okay. For normal goods. Well, here we go. If you consume more of something when your income goes up, we call that a normal good. We call it normal because, well, that's the way most goods behave. If you like something, well, if you don't like something, you wouldn't take it for free. So you're not going to be buying it. It's not a good for you. If you will buy it at some price, that means you like it to some degree. If your income goes up, you can afford more of it, you're probably going to buy more of it, as well as more of everything else. So the Engel curve is positively sloped. As your income goes up, you buy more of the thing. That's the example we saw before. But that's not the way all goods work. Some things are inferior goods. An inferior good is something where your income goes up, you buy less of it. Now, remember, this is as your income changes, not as the price changes. Unless it's a Geffen good, as the price of something goes up, you will consume less of it, all else held constant. Here we're talking about whether you buy more or less when your income changes. An example of an inferior good, I think those of you who took principles with me, I think should remember this example. Bill Gates in college, he probably ate a lot of ramen noodles, just like I did in college, as I assume you do in college, because college students are generally not rich. Do you think Bill Gates buys a lot of ramen noodles now? Probably not. Ramen noodles are an inferior good. As your income goes up, you tend to buy less of it. So on an Engel curve, this is for a normal good, good 2 and good 1. As your income goes up, the budget line goes out, you'll buy more X of commodity 1 and more of 2. Here, as your income goes up, you move to this budget line, then that one, then that one. Well, as your income goes up, you're buying more and more and more of thing 2. It's a normal good. But as your income goes up, well, from here to here, you are buying a little more of quantity 1, but as your income goes up more, you start to buy less of commodity 1. So the income expansion path or income offer curve does not continue up to the right. It starts to bend backwards. When it goes that direction, that tells you it's an inferior good. And these are the corresponding Engel curves. For commodity 2, as your income goes up, you buy more. But for commodity 1, as your income goes up, at first you start to buy more, but then you start to buy less. It becomes an inferior good. It is not possible for both goods to be inferior with well-behaved preferences. Think about what that would mean. If an inferior good, when your income goes up, you buy less of it. Well, if both things are inferior, that means your income goes up, you buy less of everything. Assuming there are only 2 goods available. That's not a well-behaved, it's not impossible. So that would not be a well-behaved utility function. Let's see here. An ordinary good. This is the first law of demand. Its price goes down, all else held constant, you buy more of it. Well, there is an exception to that rule, something that violates the law of demand. Geffen goods. This is an ordinary good. The price of thing 1 starts out here. We're holding income constant. The price of thing 1 goes up. Budget line moves to here, then moves to here. Well, the quantity of thing 1 you're buying, the price of it goes up, you buy less of it. And you have a price offer curve that looks like that. And a standard demand curve. Higher price, lower quantity. For a Geffen good, it would look like this. The price of thing 2 is held fixed, income is held fixed. The price of thing 1 starts out here. Then the price of it goes up. And the price of it goes up again. Let's look at the curve. You can see that at this part of the price offer curve, as the price of it goes up and the budget line swings in, from here to here, you actually end up buying slightly more of this thing. The blue dot is slightly to the right of the red dot. This is what the demand curve would look like. As the price of thing 1 goes up, you actually start to buy a little more of it. Geffen goods, they're named after Sir Robert Geffen. Um, he was a late 19th century economist. Um, it's tough to come up with practical examples of Geffen goods. There's still disagreement about whether they really exist in the real world. Um, some economists say no, they don't really exist. I tend to think they do. They're just very rare. Why would you, whoops, let's see, ordinary goods. Let me get back to the Geffen good example. Here we go. Why would this behavior occur? If the price of something goes up, why would you buy more of it? The classic example was in mid 19th century, early 19th century, 19th century London. Poor factory workers, their income was spent mostly on food. The cheap food was potatoes. The expensive food was meat. So you could afford, on that kind of income, to buy, hypothetically, a whole bunch of potatoes to give you enough calories for you and your family to survive one more day. But if you did particularly well one week, maybe you could usually buy a little bit of meat as a luxury. Then, if the price of potatoes were to go up slightly, because most of your income was spent on potatoes, that would be a big hit to your budget. You'd have to economize somewhere. The price of the thing keeping you alive has gone up. You're going to have to cut something out. Are you going to cut out potatoes? After all, price of potatoes went up. The normal law of demand says you buy less potatoes, fewer potatoes. But you're at the edge of starvation. You can't do that. If you have to cut something else, you cut something out. You're going to cut out meat. You can't afford that luxury anymore. So you stop buying the little bit of meat that you had been purchasing. Well, if you buy less meat and you want to stay alive, you're going to have to buy more of something else. You're going to buy more potatoes, because potatoes are still, even at the higher price, a cheaper source of calories than is meat. Price of potatoes goes up, puts a crimp in your budget, you cut out buying meat. So as the price of potatoes goes up, you can perversely end up increasing the quantity of potatoes you buy. It's even if it exists in the real world, still it's unusual enough you're not going to run across them very often. That is everything for today, and I will see you next time. Thanks for watching.